Good afternoon, everyone. Sorry if you hear Rocky and Wrigley in the background. First they were fighting over a blanket, and now Wrigley is crying for attention, and Rocky is chewing a bone. So, quite eventful here late at night. So today we're going to talk about conditional probability, and it's exactly what the name says. It's what's the probability of something happening when a particular condition already occurred. So, for example, what is the probability that a person voted for President Obama if he or she was already a Republican? So you know that this person is a Republican. What's the probability that they voted for Obama? Okay. Or, for example, suppose you roll a six-sided die with your eyes closed. What is the probability of rolling a 2 if you are told that you rolled an even number? So think about this. You normally have a six-sided die, and the probability of rolling a 2 would be 1 out of 6. But then your friend tells you that you rolled an even number. Well, how many even numbers are there? There's 3. So it's 1 out of 3. Okay? So it basically what it allows us to do is to take our total number of outcomes and kind of cut that list down. So the probability the event B occurs given that A occurs is called the conditional probability of B given A. And then this would be our probability statement right here. That little bar in between B and A means conditional probability. So event A already occurred. Okay. All right, so in the first example, we're going to use tables, and it asks us to find the probability that a test subject stayed healthy given that he or she used an experimental drug. So once again, it's really important to write out probability statements. And how do you know that this is going to be conditional probability? Well, there's a couple key words here. It says given that. So it already occurred. So I like to highlight the conditional probability. I had to pause there for a few minutes because I'm sure you could hear Rocky in the background on his bone, but he's taking a break now, so we're going to resume. So like I was saying, I like to go ahead and highlight the given for the conditional probability. And then when I write my conditional statement, I have what's the probability of somebody being healthy given that they use the experimental drug. Okay, so we have all these test subjects over here to the right, and we're going to be able to cut that list down in the sense that we already know they use the experimental drug. So we're only now looking at this group instead of all of the test subjects. Okay. So now our denominator becomes 3,100. And then what's the probability that he or she stayed healthy? So then you look at the healthy, which would be 900. And that's your probability, which of course reduces to 9 over 31. So it's almost, you kind of want to think of it as like a shortcut. That you don't have to look at the big picture entirely, and you can just focus on what was already given to you. Okay, so another example below this. So the table shows the number of students who are varsity athletes. Find the probability that a student is a varsity athlete given he or she is a sophomore. So once again, there's that key word that it's a given. Will it always be that straightforward? No. Instead of saying given, it might say you know. So like you already know this occurred. So what's the probability of a student being a varsity athlete given that that person is a sophomore? So this is the event that already occurred. So I go over to my sophomore list, and I add up the total number of sophomores that there could be, which would be 316. Okay, and then once I get that number within that green box, I look for the number of varsity athletes, which would be 28. Okay, and that reduces to 7/79. So basically, we took this whole big list of outcomes, cut it down to sophomores because we already told that the athlete was a sophomore, and then within those sophomores, how many were varsity athletes. Okay. All right. So the actual formula, and for most problems you can do it the way that I just taught you, but the actual formula is the probability of A and B divided by the probability of A, which is the given. So if we go back up to our very top example up here, and we apply this formula, the first thing we would do would be the probability of A, the denominator. So the probability of A, which is the fact that the patient used the experimental drug, well, there's 3,100 that use the experimental drug, and if we would add up all those numbers in the box, there would actually be at a total of 4,400. So that would go on the denominator here. Okay. And then we would do the probability of A and B happening. So what's the probability of being healthy and using the experimental drug? And that number would be 900 out of the total number of outcomes. Okay. These are just going to cancel out. You get 900 over 3,100, which is just still over 9/31. Okay, you can do it both ways. There is an example at the end of the notes that you do have to be able to use the formula. But for most problems, you can just apply like common sense that, if a number, for example, with the dice is even, then the only possibilities would be 2, 4, and 6 is a total of 3 outcomes. Okay, so we use a lot of conditional probability with dice and card type problems. So first of all, it says a pair of dice is rolled, find the probability that the sum is 5, given, and here's that conditional statement, that their sum is less than 6. So we would say probability of a sum of 5 given that the sum is less than 6. Okay? Now you could write out the entire, actually I should rewrite that. The sum is less than 6, not that the number was less than 6. Okay, so some of you will figure out on the sum chart that the first outcome is a 2, and then each diagonal we keep adding 1 all the way until we get up to 7. And once we get to 7, then we would start going back the other direction. Okay, so we know that the sum is less than 6. So what that allows us to do is it allows us to take our 36 total number of outcomes and cut it down to this group right here, because these are all numbers that are less than 6. So how many total outcomes am I down to now? Okay, hopefully you see that there are 10. And out of that 10, how many are sum of 5? Well, that would be 4. So that reduces to 2/5. Okay. So it just allows us, once again, to take a big list and cut the numbers down. So find the probability that the dice match, given that their sum is greater than 9. So we have 12, 11, 11, 10, 10, 10, and 9, 9, 9, 9. If you're not sure how I'm doing this sum chart, remember you can always refer back to your notes on where that sum chart is. So we already know that the given that their sum is greater than 9. So these numbers have sums greater than 9. And then for it to say that the numbers match, well, that literally means that the numbers have to match on the dice. So like 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and 6, 6. Okay, so then that gives me, and we didn't write our probability statement, so the probability that the dice match given the sum is greater than 9. Okay, so sums greater than 9 have a total options of 6, and then out of those 6, 2 of them would be examples where the dice match. All right, so next example, here's these card problems. So it says, what is the probability of drawing a face card if you already know that it is a diamond card? So it takes that list of 52 cards and cuts it down to 13 cards because there's only 13 cards in a suit. So probability of drawing a face card given that the card is a diamond. Okay, so how many diamonds are there in a deck? 13. Out of those 13 diamonds, how many are there face cards? Well, Jack, Queen, and King. So 3 out of 13. Okay, next example. What is the probability of drawing King if you know it is a card? Once again, how do you know this is conditional property? It is either it'll say given or you know. So probability of drawing a king given that it is a red card. So this given allows us to take the number of outcomes and kind of cut it down. So if there's 52 cards in a deck and we know that it has to be a red card, then we actually start off with only 26 cards. And then out of those red cards, red cards, how many of those are king? 2. So 1 over 13. Okay. All right, well, let's do one more. Let's do number 6. What is the probability of drawing a heart given that it is a face card? So here's my conditional probability because it says you know. So probability of drawing a heart given that you already know that it is a face card. Well, once again, the given allows us to cut the list down. So how many total face cards are there? There's 12. Out of those 12 face cards, how many are hearts? 3. Jack, Queen, and King. Okay. All right, we have 2 examples left. In a math class of 20 students, 10 have graphing, 8 have scientific, and 2 don't have a calculator at all. A student is selected at random. If the student has a calculator, what is the probability that she or he has a graphing calculator? So here's our conditional statement that the student has a calculator. That's our given. What is the probability that he or she has a graphing calculator? So probability that the student has a graphing calculator given that the person is already known to have a calculator. Okay, so how many total calculators are there for the students? There's 18. Why is it not 20? Because it did say that 2 students don't have a calculator. And then how many of those are graphing calculators? Well, there's 10. So 10 out of 18 gives me 5 9s. going to jump all the way down to the very end of the problem. We're going to do the notes. And it says, suppose that E and F are two events, not evens, and that P of E equals 0.4, and F, and this should say probability of F given E is 0.6. What is P, the probability of P of E and F together? So this has to go back to what we did above on the last page of notes to use the formula. So the probability of F, then it's the probability of them both together divided by the probability of the original condition. Okay, so we have the probability of F given E, it's given into you in the problem, that's 0.6. Okay, and we have the probability of E. So the denominator is 0.4. So then the numerator is what we are trying to find. Think about this as an algebraic problem. Okay, how would you do to, let's say this is a variable on the top, you would multiply these two together. So the probability of E and F is 0.24. Okay, a couple of things. If you were not here to take the quiz last Friday, make sure you get in to do those. We'll hopefully do quiz corrections on Thursday if I'm back. As always, you guys, please help each other out, especially because this stuff can get a little bit tricky with certain problems, so it's helpful to have somebody to bounce ideas off of each other. And I just lost my train of thought. Sorry, it's been a long couple days. Make sure you guys help each other while you guys are doing homework. And I provided the sub, which I think is Mr. Jonas, the answer key to the worked out solutions for the homework to put on the podium so you guys can check your answers as you go and not just kind of what the answer is or isn't. Okay? Thank you. Sorry for not the most entertaining video in the world, but I hope you all have a wonderful day. Thank you.